In my earlier videos, I showed you how to solve systems of linear equations with 2 variables. In this video, I'll show you how to solve it with 3 variables. The method is the same. We can solve them by elimination or substitution. Which method you choose will really depend on the way the problem is set up. Solve the system and state the solution set. If there are no solutions or in any solutions, state so. So I wrote my first equation, 4x minus 8y plus 4z equals 4. I call it equation 1. And in my previous video, I used Roman numeral so that we don't get it confused with the actual equation itself. You want to make sure you don't write your letters in such a way that it can be confused with a number. I use cursive for all of them. I use cursive X, cursive Z, so that my X's do not get confused. Multiplication signs, my Z's do not get confused with number 2, and my Y's do not get confused with number 4. Please review my handwriting video. Also, we keep our equal signs in the same column to ensure that everything stays neat and easy to read. Now, when you're working on problems like this, I also recommend that you start with a fresh, full, clean sheet. Do not try to squeeze your equations or your work into a half sheet of paper or a quarter sheet of paper where you have a whole bunch of numbers from another problem. So, for equation 1, I divided equation 1 throughout by 4, which leaves me with x minus 2y plus z equals 1. So it's also a good idea to make sure you copy the question correctly as you go before you go too far in the problem. If you were to miscopy the question, you may not know where you went wrong, when in fact what went wrong was you copied the question incorrectly. 1, which I divided by 4 to give me equation 2, and I've copied down the other 2 equations and named it equation 3 and equation 4. Now we need to figure out what we're going to do, whether we're going to solve by elimination or substitution. In this case, if you notice, I have a plus z, a minus z, and a minus z. So elimination, because I can just add equation 2 and equation 3 together to eliminate my z. And then I can add equation 2 and equation 4 together to eliminate my z. We always want to eliminate the same variable first. Either it could be x, y, or z, but you have to make sure that you use 2 different equations to eliminate that same variable. So because I have a plus z and minus z, I can add equation 2 to equation 3. So x plus x gives me x, 3y minus 2y gives me y, and 1 plus 0 gives me 1. And I'm going to label that equation 5. Now I want to use a different pair of equations to eliminate my z. So I'm going to use equation 2 and equation 4 because I have a plus c and a minus z. So if x plus 6x gives us 7x, negative 2x minus y gives me negative 3y, and 1 plus 9 gives me 10. And if you note, I try to keep my x's in the same column, my y's in the same column, my equal sign in the same column, and my constants in the same column. I've then also label it equation 6. We have 2 variables and 2 equations. We have x and y to find. So we can solve it either by substitution or elimination. Now we have a y here, so I can either multiply the entire equation 5 by 3 and do it by elimination, or I can say that from equation 5, y equals 1 minus x. We call this equation 7. Then I can say substitute 7, our equation 4. It's 7 minus 3. Now our y has now become 1 minus 2x equals 10. And we're going to simplify. So we have 7x. We're going to use our distributive property. So 3 times 1 is 3 with a negative in front. Negative 3 times negative 2x will be positive 6x equals 10. Simplify. 7 plus 6 is 13x minus 3, which equals 10, plus 3 on both sides. That gives me 13x equals 13. That's a nice number because when we divide both sides by 13, we can say that x 1. Now I'm going to find one of my equations where I only have 2 variables with one of the variables being x. So I can use equation 5, 6, or 7 because I know my x now. And I'm going to use equation 7. So I get y equals 1 minus 2 times 1 from equation 7, which gives me 1 minus 2, and therefore y equals -1. Now these are nice numbers, so that's a good sign that we're on the right track. More often than not, if you get a weird number or a fraction, you're on the wrong track. These questions usually will give you nice numbers. So we have now found x and y. We need to plug it back into one of our three original equations. You can use any one of these. I'm going to choose one that has smaller numbers, which is equation 2. I'm just going to rewrite that from equation 2, x minus 2y plus z equals 1. My y is -1, and we're trying to find out z, so plus z equals 1. Simplify. 1 plus 2 plus z equals 1, which is 3 plus 1. And if we minus 3 on both sides, 2. And we can write the solution set as 1, -1, -2, which is x, y, and z. And if you want to check your answer, you can do so by plugging in your values into any one of the equations. I'm going to choose equation 3 as a quick check. So x plus 3y minus z, is that equal to 0? Let's plug it in. 1 plus 3 times -1 minus 2 equals 1 minus 3 plus 2, 3 minus 3, which equals 0. This checks out to that. So good chance your solution is correct, but you can go ahead and plug in your final answer into another equation to make doubly sure. Subscribe to my channel, hit the bell buttons for notifications. If you have any questions or comments, please leave them down below. I offer notes, lessons, worksheets with full answer keys for sale, as well as online tutoring services, links below. I also have a Patreon account if you'd like to support me that way. Thank you for joining me, and I hope you found this lesson helpful.